All right, so we are picking up where we left off. In video 1, we kind of talked conceptually about the drag force, and we came up with our differential equation for it. But a lot of times in your AP test, or just in general, the actual question is going to be derive an equation for the velocity as a function of time. So essentially, you want to take your differential equation and get it to the point where we can say v equals something as a function of time. The way to do that is by a method called separation of variables. So let's look. Solution by separation of variables. So let's rewrite our equation, but I'm going to get rid of the negative on the right half. So I'm going to say mg minus bv is going to equal m dv dt. We are trying to solve this to get to v equals, but it's not super simple because we have a v and we have dv. So this trick to this is something called separation of variables, and that's where you want to get all of your one variable on one side and the other variable on the other side. So I can rewrite this as dt equals m over mg minus bv times dv. Awesome. So now we're at a point where, hey, I can integrate both sides. We're going to take the integral. For the limits of integration, we're going to go from 0 to some time t and from 0 to some speed v. On the left side, it's nice and simple. The integral of dt is just t, and we're evaluating it from 0 to t, so t minus 0, so we just have t. On the right side, we need to do u substitution. Woohoo! Hopefully you guys remember this. If not, here's your little refresher. I'm going to simplify this. So we're going to say let u equals mg minus bv. Okay, so that means that du dv is equal to, so take the derivative of u with respect to b, it's just minus b. So du equals negative b dv, or we can say dv is equal to negative du over b. So if I go and plug our u substitution in, we can pull out the m. It's the integral from 0 to v of 1 over, well, mg minus bv is u, and dv is negative du over b. So I'm going to substitute that. I'm going to say du, and we can plug in a negative over b out front because that's just a constant. So now I actually can take this integral. The integral of du over u is something we know how to do. That's just the natural log. The negative 1 over b comes by the u substitution. All right, so let's clean this up a little bit. I'm going to say t over m over b negative. Put all the constants on one side is going to equal the natural log of u, which I'm going to plug back in, we know is mg minus bv. We are evaluating that from 0 to v. All right, let's do that evaluation. We have still negative t over m over b is going to equal the natural log mg minus bv when we plug in v minus the natural log of mg minus 0, so just mg. Okay, we can use our natural log rules to clean this up a little bit. So we still have t over m over b is going to equal the natural log of mg minus bv over mg. Now hold on, we gotta pause. Lots of crazy math. What am I trying to do again? We are trying to solve for v. So in order to do that, I need to get rid of the natural log. So we can raise both sides to the e, or e to the both sides power. So e to the negative t over m over b is therefore equal to mg minus bv over mg. Okay, again, we're trying to solve for v. So let's multiply mg up. So we have mg e to the negative t over m over b. And then bring the bv to one side, the mg's to the other. When you do that, we get that bv is equal to mg minus mg e to the negative t over m over b. Okay, we're almost there. Let's factor out an mg and divide by b. So v is therefore equal to mg over b times 1 minus e to the negative t over m over b. Oh my goodness, we made it! So v is equal to this whole mess. All right, let's look at it a little bit. So m over b, this constant over here. This is going to have the units of seconds. If you remember from our first video, and we go back to the conversation about the mg over b conversation, and we ended up saying that b is going to be kilograms per second. So if we have kilograms over kilograms per second, m over b ends up working out to seconds. So time is of course in seconds. So seconds over seconds means that this whole thing is actually unitless. This is unitless. mg over b has our units of meters per second. This is our v max. This has units of meters per second. So essentially, this bracketed quantity, this 1 minus e to the negative t over m minus b, is a value anywhere between 0 and 1. It's going to be 0 to 1. It's really the decimal percent of Vmax. So if you think about the values that these are going to take, if you start plugging in your calculator to 1 minus e to the negative 1, 1 minus e to the negative 2, etc., you're going to get that this term is always going to have a value between 0 and 1. E to the 0 is 1, so 1 minus 1 is 0, and then as we go negative other values, this is going to approach the limit of 1. So that's kind of cool. We can actually graph that. If we put it into graph form, hopefully more things become clear. So let's write this. Here's my velocity. Here's my time. And just for the sake of simplifying it, I'm going to rewrite our equation. I'm going to say that v is actually equal to mg over b times 1 minus e to the negative t over tau with tau is equal to m over b. So we're going to create this thing called a time constant, and we're going to call it tau. Tau's a real number. This, we're going to say, is defined to, we're going to throw that to the other side, defined to be time constant. So you would know the mass, you would know the proportionality constant. You could say, all right, tau is a number. Let's say tau is 2. Okay, so if tau is 2, if m over b is 2, then I want to figure out, all right, what maybe is the time when t is 2 seconds. I'm making numbers up. We can say, what if t is 2 seconds? If t is 2 seconds and m over b is 2 seconds, then we have the situation where t is equal to m over b. If that's the case, what we have, you get 1 minus e to negative 1. Well, that's equal to 0.632. So if time is 2 and m over b is 2, we are at 63% of our max speed. Okay, what if we want to know the time of 4 seconds? Okay, if we want to do 4 seconds, if, t is equal to 4 seconds, which would be twice tau, then we would have 1 minus e. 4 over tau, which was 2, would be to the negative 2, which ends up being about 0.86. So it would be 86% the max velocity. So if I wanted to graph that, we can say this is Vmax. This is my limit. This is the most that it's going to ever get. And my function is going to do something like, we'll go green, something like this. It's going to start at 0 and increase. And if we wanted to just put some points in, we can say, all right, this is when t was equal to, I'm going to write tau, but again, it's just some number. We were at 63%. That is very not drawn to scale. Let's fix all of this. Let's redraw my curve. Try again. That looks a little better. All right, so now we're at t equals tau. Here we are. This is 0.63 Vmax. And then we can put in another point. We can say t equals 2 tau. And this was at 0.86 Vmax. And again, in a problem, another way that they could phrase this question is, all right, I want to know how long does it take to get to 50% of the speed. So what I would want to do would be say, okay, I'm going to look at 50% of the speed, so 0.5 Vmax. What is this t? Well, I would take my bracketed term. I could say 1 minus e to negative t over tau. When does that equal 0.5 and solve for t? Hopefully that makes sense. Oh, one last thing. So sometimes also you'll see on an AP test, it won't ask for a function of speed, but it'll ask for a function of acceleration. If it does that, of course, you guys would remember that a equals dv dt. So you would just take the derivative of whatever you got for your velocity function to get your acceleration. Luckily, luckily exponential functions are easy to take the derivative of. It's just e to the u times u prime. That's on your formula sheet if you forget that. So you could do that. And I think I hit everything. We'll see. Hopefully I did. Hopefully this made sense. I wrote a lot. All right, cool. I'm going to call it a day and let me know if you guys have any questions. Okay, bye.